back with part 2 of our teaching on sets and Venn diagrams. But first, what would you get if you crossed the bridge with a car? Well, of course, you would just get to the other side. And then the second one that I have for you while I'm getting my papers together here is, what do you put on top of a doghouse? Well, you put a wolf on top of a doghouse. So, page 78 in our text, we've talked about sets, and we know that sets use a capital letter. And I'm just going to say that a set right here is this one right here, the set S that contains, is that up there? That contains the elements S, the set S contains the elements 0, 1, 2, and 3. And if we were to use element, we would know that 3 is an element of set S. We would also know that 5 is not an element of set S. But we also would know that, let's just say we have another set here. We have set B, and we say that set B is the set that contains the elements 1 and 2. Well, we can say, look right here, set elements 1 and 2, elements 1 and 2. We can say that what you've got, that B sort of fits inside of set S. And the way they use this in set language is to say that B is a subset of S. In other words, every element that is contained in set B, which are the elements 1 and 2, every one of those elements you can find in the larger set. So it's always going to go from smaller. The smaller is always going to, will be a subset of the larger. I meant to write larger instead of that S, but S is the larger subset. Smaller is a subset of the larger. It's never going to be that the larger is a subset of the smaller, because if you have something bigger, you can never have all of that contained in the smaller set. You can't squish all of this, 0, 1, 2, 3. You can't find all of that in here. That's more of what we've been talking about. You can't fit God into our box. You know, there's more to God, there's more to set S than there is to set B. So the smaller set will be a subset of the larger set. So this right here, notation that we have is subset. Means it's a smaller part of the whole set together. This right here, of course, means not a subset. More math vocabulary. Seems like there's vocabulary in everything. I was working with some kids yesterday doing calculations in chemistry. So we have specific heat, we have we have joules per gram degree centigrade, we have milliliters, we have kilograms, we have vocabulary in French, we have vocabulary in Spanish, we have vocabulary in ASL, in American Sign Language. No matter what you're working in, you have to understand the vocabulary of your topic in order to be able to do it. And that's a given. And that's what this section 2.7 has been. It's a lot of vocabulary. There's one final word, well, two final definitions actually. You have empty set and you have the null set. The null set. And what do you think an empty set might be? What do you think it is? Well, it's a set that doesn't contain any members. Isn't that strange? Null set has no members. It's another way to write null. There is no solution. The set contains no members. And this empty set right here, they consider that to be a finite set. That's just by definition. And I can't think of any time when I've really used that, but your book mentions that, so I want to make sure that I point that out. Let me get this example number 5 for you. And this says, which are not subsets of set C above. So let's go ahead and rewrite set C. And that was the one that we did. We had C was a set that contained the elements, I believe, 1, 2, 3, 4, and 5. So let's flip back to the other page and make certain, yes, and it had 6. This is what I did the first time also, 5 and 6. You know, when you're teaching, it doesn't matter if it has 5 elements in it or 6 elements in it, unless we're trying to do examples that are specifically related to that set. So, which are not subsets of set C? Which are not subsets of set C? Okay, well first we have is C union D a subset of set D and of set C, and we had that D was 2, 4, 6, 8, and 10. Well, what does CUD mean? It's C union D, and that means that's every element that is contained in set D and every element that is contained in set C. Well, no, because even though you have 2, 4, and 6 in set D, 8 and 10 aren't in there. So no, it is not a subset. Not a subset. What about the element, or the set that contains the element 5? Is that a subset? Sure. 5 is right there. Now, what about 6? Is 6 a subset of C? Now this says, is 6, okay, this is a subset, is just 6? No. Now why is this not a subset? Look, it's got 6, but what it's missing, and this is being real technical here, but what it's missing is these braces. 6 by itself is not a subset. It's not a subset of anything, of any other set. It's not a subset of another set because it isn't a set itself. It is not a subset because it doesn't have that set notation on it. Next we have is C intersect with D, a subset. C intersect with D? Well, sure it is. C intersects, wherever C and D intersects, these are the elements that they have in common. So you have that new set, which would be the set that contains the elements 2, 4, and 6. So yes, the intersection, the set defined by the intersection of C and D would be a subset, because that subset is written as 2 for the set that contains the elements 2, 4, and 6. Now don't get too totally hung up and frustrated with these. Go through them, figure them out, but realize that on a scale of 1 to 10 order of priority for essential information for building on in algebra, this isn't really very high, but you still need to know, you still need to be familiar with it. There will still be questions on the test about it, so take your time to understand what's going on with it. I'll see you next time.